For this synthesis problem, we first observe 6 carbons in the starting material, 6 carbons in the product, plus these two. And I don't necessarily consider those part of the main chain. I would consider this whole piece here to be a new functional group. And I think it's a little easier if we think about it that way, because obviously, yes, we're adding 2 more carbons, but they come along as part of that ethoxy functional group, and of course the chlorine is no longer there. So the question becomes, how do we add this ethoxy functional group to the original 6 carbon chain? And there's one way I can think of to do that, and it involves a SN2 type mechanism where we take a relatively unhindered strong nucleophile, strong base, ethoxide, and react that with the primary alkyl halide here. And this might lead to a little bit of E2 elimination, but the fact that it's primary and the fact that we have a relatively streamlined, unhindered nucleophile, we can probably get our major product to be the desired substitution product. So that's what I would do here, and that shows us that we need to take our original 6 carbon molecule and essentially migrate our leaving group to the end of the chain. And that's one of our synthesis problems where we changed the position of a leaving group. And so in order to do that, we need to think about how to get a leaving group on the end of the chain. Well, if we don't use chlorine, but we use bromine, we do know how to put a bromine on the end of a chain. And that's the HBr peroxides reaction using a simple alkene. We can get the bromine to add anti-Markovnikov on the end of the chain. And then in order to get here, we just need a simple E2 reaction. And if we use a large base, this should be a minus here, if we use a large base, we can favor removal of this hydrogen instead of the interior hydrogen and produce a large amount of the 1 hexene instead of the 2 hexene. So we can remove the leaving group, forming the Hoffman product alkene, and then we add HBr and peroxides, and that gets us a Br on the outside, a primary alkyl halide. That's a very great substrate for an SN2 type reaction, and so we can use ethoxide here to put on the functional group on the outside of our chain. Alright, so the second one also involves 6 carbons. Apparently I was on a 6 carbon kick when I wrote these problems. And we have a functional group sort of on the end, you might call it on the 1 and the 2 position, and then we have our functional group now is on the 2 and the 3 position. So let's think about how we can get our functional group to move over. Well, we know how to make anti-diols. That is with, first step is some peroxy acid, followed by H3O plus to ring open the epoxide that forms, and we react that with the appropriately shaped alkene. In this case, we want the E alkene, and we're going to add OHs on both sides of the alkene in an anti-fashion. How do we get to the E alkene? Well, now this reaction becomes a migration of the alkene type problem that we might have seen at the end of the addition to alkene chapter. So in order to move the alkene, we have to install a leaving group first. So if we just had HCl, we can get something like that. And then if we use an appropriate base, let's just use a really small base, methoxide, we can remove the interior hydrogen in preference to the exterior hydrogen and come up with this internal alkene. And if we let nature take its course, we should end up with more of the E alkene than the Z alkene. But of course, if we got the Z alkene, we can still get to the product by choosing an appropriate reagent. So if we add, let's see, if we add anti to this Z alkene, we're going to get something like this. And I think you'll agree that that won't give us the proper arrangement in the product. This will give us what appears to be, if I rotate around this bond, we'll get this, what appears to be the syn version. So I don't want to use the same set of reagents here. Actually, I want to use reagents that will give me the syn version. So if I can produce this, then I can rotate around that indicated bond and end up with my desired product. So how do I add OH's syn? Well, that's just OSO4 as our reagent. So we could take our Z or our E alkene and through appropriate reagent choice turn them both into this desired product. Okay, one last one here, and it's relatively simple migration of the alkene. In order to produce an alkene here, we'll probably want to have our functional group in that tertiary position, use the appropriately sized large base, and we can get the alkene sort of on the, we call it an exo position, or on the outside. And in order to get the functional group on this tertiary position, we need to somehow react this alkene with the goal of eventually getting a functional group over on the tertiary position. So I can put a functional group a little closer if I simply react with HCl, and then I can eliminate the HCl using, if we use a small base, we can get the favored tri-substituted alkene. And of course you can see how another dose of HCl with this tri-substitute alkene should give us to our desired tertiary alkyl halide, which we can then do a Hofmann elimination using the large base to produce the less substituted alkene. So this is simply a migration of the alkene a couple different bonds, or a couple bonds down the chain. So this is simply manipulating the alkene.